So as I mentioned in the previous video, the main idea with using matrices in the setting of solving systems of equations is to solve it in a more organized way. So you think about the things we can do with a system of equations without changing the answer, and the same thing is true for matrices, and this is where row operations come from. So if you interchange two rows, you haven't really changed the system of equations. It's no different than writing the system in a different order. Now, as we talk about row operations, it's also important to talk about notation for this. So what I'll show you is actually two notations for this, the shorthand and then the more longhand notation. So let's just make up a matrix here. We're not going to try to be too creative. So 1, 2, 3, 4, 5, 6. So here's a matrix. Let's say I wanted to interchange these two rows. This would be row 1 and row 2. Shorthand notation, I could just do something like this. Now you want to do this whenever you're working with matrices so that if there's a minor mistake, you can quickly fix it. You can go back and see what you meant to do and what you really did. Okay, so that would be no different than, like I said, rewriting a system of equations in a different order. It may not seem very useful when you're actually solving a system of equations with our old methods, but it's going to be useful when working with systems in matrices. Okay, what about the other notation for this? And this is your textbook's notation. So I'll take my original matrix. Let's say I wanted to switch these two rows. Then what I'm going to do is I'm going to say, okay, I want to switch rows 1 and 2. And so they would say something like row 1 and then double arrow row 2. And then they would write the new matrix below it. Both are correct. I figure you probably want to use the shorthand when actually working problems, but you want to know the longhand because that might be used on an exam and it's definitely used in the book. Okay, what else could we do with a system of equations that's useful? Well, think about elimination. A lot of times we'll multiply one of the equations by a value. And so if it's non-zero, we haven't changed the equation at all, as long as we multiply both sides of the equation. So you could do that with a matrix as well. And since a row represents an equation, you're essentially talking about multiplying a row by a constant. So let's make up another matrix. I'm going to make a little bit of a bigger matrix this time. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say that what I wanted to do was multiply row 3 by 2. Now, don't ask why I would do that. I'm just making it up. The shorthand notation, I would just say, well, I want to multiply row 3 by the number 2. So I say, okay, that'd be 1, 2, 3, 4, 5, 6. And then now this will be 14, 16, 18. Again, this may not seem very useful, but it might be because, as we saw in elimination, that's useful. Okay, what about the other notation for this? So I'll redraw my matrix real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, remember what I want to do. I want to multiply row 3 by 2. So what I would say is I want to take 2 times row 3, and I want to put it where row 3 is right now. So I want to replace row 3 with 2 times row 3. So this will be where you're putting the operation. This is the operation you're doing. And now I would get the same value, 1, 2, 3, 4, 5, 6, and then 14, 16, 18. Okay, again, the same idea, just two different ways to note it. Okay, so let's look at one more, and this time I'll write down what I want to do. I'm just going to make up another operation. Let's say that I want to multiply row 1 by, let's say, 3 and add it to row 2. You may say, why would you want to multiply a row by a number and add it to another row? And then I take you back to elimination. That was something we did all the time to eliminate variables. And in a matrix, we're going to do sort of the same thing. All right, well, I'm going to use the matrix I just used in the previous step. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, in the shorthand notation, what I do is say, okay, I'm multiplying row 1 by 3. I'm adding it to row 2. So everything's happening in row 2. So here I can say plus 3 times row 1. Now, this is something you should practice quite a bit. How does this operation work? Well, 1, 2, 3 doesn't change in the matrix, but this row does. That's why I put the operation there, because we're adding it to row 2. So what I would do is each element in row 1, I multiply by 3 and add it to the corresponding element in row 2. So 3 times 1 is 3 plus 4 is 7. 3 times 2 in row 1 is 6 plus 5 is 11. And 3 times 3 is 9. 9 plus 6 is 15. And now I get my 7, 8, 9. So again, doing that operation may or may not help me when I'm trying to eliminate a variable. In fact, notice if I had used -3 here, I could have eliminated something down here. Okay, what about that longhand notation? Well, same idea as before. In other words, you're going to put an arrow to where this is going. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my original matrix. And so now I'm taking 3 times row 1. I'm adding it to row 2, right? And then where is it going? It's going to where row 2 is. So everything's happening in row 2. That's the notation here. You should be very comfortable with that, even though it's a little clunky. And if you do that, you end up with the exact same answer. So really, you should be comfortable with both of these. You should be able to do row operations by hand. I am going to show you some tricks on the calculator, but 100% going to ask you to do these by hand on some cases on exams and everything. So if you just do it with the calculator, you couldn't get credit, right? So you want to know how to do it by hand, and you want to be comfortable writing down either notation, because this will be for you, knowing what you did. But then if the textbook's using this, you want to know what they did in the examples.